So ladies and gentlemen, we have a question to determine the volume of a solid of revolution resulting from rotating a curve y is equal to x squared plus 3 around the x-axis over the interval from 0 to 1. Now, if you want, we can sketch. First of all, when x is equal to 0, y is equal to 3. Okay. Then when y is equal to 0, this becomes complex. So that means y should never be 0. And so that means it will never cut the x-axis. So let's have something of the sort. And we are saying when x is 0, the equation passes around here. So we don't know, this is 3. But if we say the y, the x, this gives us 2x. And that means the minimum, when I get this equal to 0, I'll get the minimum. So x will be equal, x is equal to 0 is the minimum. But if I substitute in the equation, I find that I have 3. So that means that equation is likely to pass there. So if I'm to revolve this around the x-axis, what would this form? So you can see that it's going to form something. It is going to look like it. So hope that is understood. So the radius of this other side is generally going to be y. So meaning my area is going to be pi y squared. So volume, remember this is the x-axis. Volume is going to be integrating. The limits given to us is from 0 to 1 of area with respect to x, meaning that volume of that solid between 0 and 1 is going to be integrating from 0 to 1 of pi y squared with respect to x. But we know y, so this is from 0 to 1 of pi, y is equal to x squared plus 3, then we square with respect to x. So volume is going to be pi, then integrating from 0 to 1 of x squared plus 3, everything is squared. Now we need to use what we call either binomial or Pascal's triangle to determine, to relate a plus b squared with this. So this becomes a squared plus 2ab plus b squared. If it was bigger, in other words, that won't be volume, but in any case, if you find that what you're going to integrate is like power 3 here to power 4, you can use Pascal's triangle and be able to get those the powers and probably the coefficients that you need to involve in. So x squared plus 3 squared, this is going to be x squared square plus, that is a, plus 2, okay, into x squared into b is 3, then plus what else? Plus, obviously this is going to be 3 squared, and that is 9. So this is x to the power 4 plus 6x squared plus 9. And if I integrate that, volume will be integrating pi times 0 times the integral from 0 to 1 of x squared plus 3 squared. This will be the same as pi integrating from 0 to 1 of x to the power 4, 6x squared, 9, okay, 9 with respect to x, and therefore the volume will be pi into, this is x to the power 5 out of 5 plus 6x cubed out of 3 plus 9x from 0 to 1. So that will be pi into, this will be 1 out of 5 because 1 to the power 5 is 1. So divide by 5, that will be 5 plus 1 out of, that is 1 out of 5, then plus 6 divided by 3, that is 2 into 1 cubed. So it remains as 2, then plus 9 times 1. So minus 0, it will be 0. So volume will be 11 plus 1 out of 5 into pi. This is going to be 55 plus 1, and that becomes 56 pi out of 5, and that is in cubic units. So we must understand how to get the radius which is y, and that radius is always going to be the function which is given as, for example, in this case is x squared plus 3. That's what you square, you multiply by pi. If you integrate that, you'll be able to get the volume between the limits that have been given to you. So that's how we can get that volume.